Good morning, students. Welcome to the course Circuit Theory and Network. Today we are going to discuss how you can solve the electrical circuits. So to solve the electrical circuit, there are different methods to solve any electrical circuit, like loop analysis, nodal analysis, and several theorems are also there. First of all, we are going to check how we can solve a circuit very easily, whether there are different types of voltage source or different types of current source, right? So today's topic's name, that is the methods of analysis. Okay, so now we are going to our next slide, where the topics that is covered by today's lecture, that is the introduction and what is actually the nodal analysis. If any circuit consisting with different voltage source and different current source, then how you can solve it, and as well as what is the nodal analysis and mesh analysis, and the comparison between their nodal analysis and mesh analysis. So first of all, before going to the nodal analysis, first of all you have to know what is node. So node is nothing but the junction point for a circuit. The junction point means where more than two branches meets together, or the connecting points where more than two electrical components are connected together. That point is considered as a node. So this is the basics of nodal analysis, that before going to the nodal analysis, first of all you have to find out that how many nodes are there. Okay, so we will consider the nodes only where the more than two branches meets together, and for each and every node, first of all, suppose for any circuit we are getting four numbers of nodes are there, suppose four numbers of junction points or nodes we are getting. So among these four numbers of nodes, what we do, actually only one node is being considered as a reference node. Reference node means we are considering the node having a voltage of 0 voltage. It means that node is considered as a reference node. And for the remaining nodes, all the remaining nodes, it means if there are n numbers of nodes, then the remaining n minus 1 numbers of nodes are the non-reference nodes. So what is the purpose of these non-reference nodes? Now these non-reference nodes, we have to assume some voltages, like the first non-reference nodes we are considering having a voltage of V1, the second non-reference nodes we are considering having a voltage of V2, similarly V3, V4, V5, and whatever the nodes, the remaining nodes, we have to put the voltage as per our choice. That is, we are considering, just remember this thing, that whatever the number of nodes are there, we are considering only one node as a reference node, and the reference node having a voltage of 0. It means the reference node is in ground potential, and all the remaining nodes we are considering the voltage like V1, V2, V3, V4, and actually this is the nothing but the unknown voltages, and our aim is to find out that unknown voltages. If anyhow we can find out that unknown voltages, our circuit is solved. So there is no problems at all. Now whenever we are going to find out this unknown node voltage, then we can find out it by applying the KCL. So I think all of us, we know what is KCL. KCL is nothing but for any circuit, for any point, the summation of all currents is equal to the summation of all outgoing currents. So that we have already seen in our basic electrical circuit. So just we have to apply this knowledge of this KCL for all non-reference nodes, and then whatever the equation we are getting, we have to solve it. Here the same thing is written over here also, that select a node as a reference node. It means whatever node we are considering, the n numbers of node, among them one node is being considered as a reference node, and remaining n minus 1 nodes are considering as a node with a voltage of V1, V2, V3, V4 dot 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 up to Vn minus 1, and we have to apply the KCL for the non-reference node. It means how many non-reference nodes we have? We have n minus 1 numbers of non-reference node. Then whatever the equation we are getting, then we have to we have to solve that equation. Okay, Next, here is some symbols. Symbols means first symbol, that is nothing but the common ground symbol, and second one, this is nothing but a normal ground symbol, and the third one, that is option C, that is the chassis symbol. So several types of ground symbol we can provide with our nodal analysis method. Okay, now here is an example. We have taken an example, the circuit consisting 3 resistance and 2 different current source, and we know that the current source means where the current source, we can identify the current source as there is an arrow symbol. This is the current source, this is also a current source having a values of I1 ampere and having the values of I2 ampere, and these are the my resistance R1, R2 and R3, these are my resistances. Now our aim is we have to find out all the currents through that branches by using this node analysis. So what are the steps? First of all, the steps is we have to find out that how many nodes are there, and what we have seen? We have seen the nodes means nothing but the connecting point between more than 2 branches. So let's see how many nodes are there. Just the lower portion here, the one branches is over here, second branches is over here, third branches is over here, this branch. So these all 3 branches are connected together and by this point, so we can consider this is one node, this one as a node. Similarly, the point 1 here is also branch 1, branch 2, branch 3, branch 4, 4 numbers of branch meets together, so we can consider this one as a branch, this one as a node also. Similarly, the point number 2, here is also 3 branches meets together, we can consider this one as a node also. So simply we can say there are 3 numbers of nodes. So what are the procedure? The procedure is that what are the total numbers of nodes, we have to consider one node as a reference, and you can take any one as a reference node, that's your choice, there is no more problem. So first of all, for the simplicity of the calculation, I have taken these nodes, these 0 nodes as this node number 0, and this is as a ground nodes, as the ground symbol is given over there and it's put it over there. So this 0, that is considered as a node number 0, that is considered as a ground, and we have put it a ground symbol in picture number B obviously. And non-reference node, that is the node number 1 and node number 2, we have to provide an unknown voltage, that is we have considered the unknown voltage like V1 and V2. So we have considered the nodes, we have taken the reference node with a ground potential, and we have already considered the non-reference node with the unknown voltage V1 and V2. Then we have to put the current, amount of current within the non-reference node. So the non-reference node having a voltage V1, there total 4 numbers of branches are connected together. So whatever the branches, we have to consider the current. So you can take the current, you can take the direction of current as per your choice, no problem at all. So first of all, we have considered this I1, this I1 current in downwards. This is my opinion, you can consider this up direction also, no problem at all. Similarly, I have considered I2. Similarly, for this node 2 or this node 2 where the voltage is V2, so we have already considered that the I2 current through this R2 resistance, that is left to right side direction. So for this node where the voltage is V2, there also we have to consider the same current. It means as the first time we have considered the I2 current for left to right, similarly through this R2 resistance, this current will be always from left to right. So that we have considered left to right option. And similarly, the current through this R3 resistance, that is I3, that we have considered, and as the I1 and I2, they are the current source and direction of current is already given. I1 current is the upward direction and I2 current, that is the left to right side direction. So all the current, we have put at the direction for all the current. So now we have to solve the circuit. How we can solve the circuit? So for this first point, that we can see for this V1, for this node, what do you know, that as per KCL, the summation of all incoming currents for this particular node, the summation of all incoming currents is equals to summation of all outgoing currents. So first let's see for this node 1, it means where the voltage is V1, which one is my incoming current? This I1 current that is going into the node, it's fine. Then this capital I2 current, these are coming from that node, it means this is the outgoing current I2, capital I2 current. Similarly, for this branch, for this R2 resistance branch, this small I2 current, this is also the outgoing current from this node 1 or the node where the voltage is V1. Similarly, for this I1 current, small I1 current, this is also outgoing current. So we can write the KCL equation that I1, capital I1, that is the incoming current, is equals to all the outgoing currents, it means capital I2, small I2 and small I1. That is written over here, that I1 is equals to I2, capital I2 plus small I1 plus small I2. Similarly, for this node point, for this node V, it means node 2 where the voltage is V2, the incoming current is only capital I2 and small I2. Capital I2 and small I2, they are the incoming current, and the outgoing current is small I3. So if we consider if we put the KCL, or if we consider the KCL, it means Kirchhoff's current law, then only we can find the summation of all incoming current, means capital I2 plus small I2 is equals to the summation of all outgoing current, that means small I3. So that's written over here, that capital I2 plus small I2 is equals to small I3. So it means the first equation is for the node 1 and the second equation is for the node 2. Now one thing we have to put over there, that is, what is the current? We know the current is nothing but a potential difference across any branch divided by the resistance of that branch. So how we can consider the potential difference? This is the general formula, that I is equals to V by R, that we already know, that we all know. So V, what is that V? V is nothing but the potential difference. So what is this? How we can measure that potential difference? We can measure that potential difference, it's nothing but the higher potential minus lower potential. It means the potential the potential of one point minus the potential of the another point of any branch. So we can consider the current for any particular branch, that is nothing but a higher voltage or the higher potential minus lower potential divided by the resistance. Now whatever the equation we are getting over there, for the first equation, that is capital I1 is equals to I2, capital I2 plus small I1 plus small I2, and just we are going to find out all these current value. So we have to find out the current value in terms of voltage and resistance. Now see, what is this I1? This I1, that is, we have considered this I1 up to down direction. So what is this values of I1? So this I1 current that is coming from V1 voltage to, we have considered this point as the ground point. So ground point having a voltage of zero potential. It means we have considered this I1 current from higher potential V1 to lower potential. Now here is the main thing that we have to understand. Sometimes here is some difficulties to write down this current in terms of voltage and resistance. Just try to remember one thing, that just like a normal analogy, just like a water analogy. So how the water comes or water flows due to the height difference. It means suppose we have a tap in our kitchens, and our the reservoir, the tank, that is situated in our 6th floor or the 5th floor of our house. So if the water is present in the tank, it means the tank which is situated in the 6th floor or the 5th floor, then only you can get the water in your kitchen rooms or in your bathrooms, whatever. So it means if the tank's water level is higher than your tap water level, then only we can get the water, otherwise not, right? So It means we can say that water flows if there is a height differences are there, and water flows from higher height to lower height, right? Similarly, the same thing happens also for the current. The current flows from higher potential to lower potential. This is the vital point, and always we have to remember this thing. So current always flows from higher potential to lower potential, and the values of the current we can find by this, by dividing this potential difference by the values of the resistance, or if we consider the AC circuit, then we have to divide this potential difference value by the values of impedance, right? So now, so as we have considered this I1 current, I1 current is up to downwards. It means this is our assumption. We have considered is from up to downwards. So obviously we have considered that V1 is in higher potential and 0 is the lower potential, right? Because we know that the current flows from higher potential to lower potential. So as we have considered this I1 current up to down, it means upside means this V1 point having a higher voltage than this 0. Similarly, for this I2 current, for the small I2 current, we have considered the small I2 current is flowing through this R2 resistance from this node 1 to node 2. It means from the voltage point V1 to the voltage point V2. So obviously we can say, as the I2 current is flowing from V1 voltage to V2 voltage, so obviously V1 voltage is higher than this V2 voltage, right? So the voltage difference will be V1 minus V2 for this small I2 current. Similarly, for this I3 current also, for this I3 current we have considered the current up to downwards. So here the potential difference will be V2 minus the current, the voltage of the point where the current is going. The current is going to the voltage point of 0 voltage. So for this I3, small I3 current, the voltage difference will be V2 minus 0. So by applying this logic, we can find whatever the currents, values of current. Okay, now simply we have considered that the I1 current, small I1 current, we can write that the voltage difference divided by the resistance of that path. Voltage difference means voltage of the starting point minus voltage of the end point. So the starting point having a voltage of V1 and the end point having a voltage of 0. So the potential difference, that is V1 minus 0 divided by resistance for this path. What is the resistance for this path where the current is small I1? The resistance is capital R1. So we can say, right, I1 is equals to V1 minus 0 by R1. Similarly, what we can write for this I2? For this I2, obviously it will be V1 minus V2 divided by this R2 resistance. Similarly, what we can write for this I3 current? So for this small I3 current, we can write V2, that is the higher potential, minus 0, this point having a potential of 0, this point, this ground point, potential 0. So for I3 we can write voltage difference means V2 minus 0 divided by this R3 resistance. Okay. So next, whatever the equation we have got in our previous case, so it means the equation number 1 or equation number 2, it means first these two equations, just we are going to put all these values. All these values means the values of this small I1, small I2, small I3, and for this capital I1 and capital I2, capital I2, you won't get the values in terms of voltage by current because they are the current source, and we know that the current source always provide the constant amount of current. So if there are any current source in any branch, so where the actual current value will be nothing but just the values of this current source. So this capital I1, you can't replace this capital I1, it means the values of this current source, you can't replace it by using this formula V by R. So where the current source values is capital I1, so this branch current will be always capital I1 and this branch current will be capital I2 always. And for the remaining case, for the remaining small I1, small I2 and small I3, you can put these values V by R. So after putting these values, we are getting the equation like this. All these values are given. So we are getting two different equation, and if the current source values is given to you, it means capital I1 and capital I2, they are the current source values, and you know the values of capital I1 and capital I2, and if we put all these values, and if we put the values of R1, R2, R3, whatever the resistance value that is given in your problem, then simply you will get the two different equation having two unknown quantity, that is V1 and V2, and after solving this equation you can simply get the values of V1 and V2. And there is the one method we can directly calculate the values of V1 and V2 by applying simply the concept of normal equation solving method, or by matrix analysis method you can also solve this equation, no problem at all. Whatever is easier to you, that you already know how to solve this equation, that you have already seen in our class 10 or 11 10 standard, and in by this matrix equation method also you have seen in your last basic electrical technology classes. So I am not going for that part, so I am going how we can just calculate this unknown node voltage for that. And now we are going for the another problem, and where the actual values is given to you. It means for this circuit also the two different current sources are there, that is 5 ampere and 10 ampere current source, and three resistance having the values of 2 ohm, 4 ohm and 6 ohm, and we have to find out the different node voltage. It means what are the nodes are there, we have to find out that voltage, or sometimes they may ask you the question like that, that what are the current for the different branches. I have to solve it by using this nodal analysis method. So this is the problem. So how we can solve it? Just like the previous method. How? So first of all you have to find that how many nodes are there. Nodes means the junction point or the connecting point for more than two branches. So how many points are there? So let's consider, here is the lower one, that is the 1 point. This is this point connects branch 1, 2 and 3 different branches. So this is, we can consider this one as a node. Similarly these points also, 3 branches are connected together, more than 3 means more than 2. So we can consider this one as a node. Similarly this point where the 4 different branches are connected together, we can consider this one as a node also, no problem at all. So there we are getting 3 nodes. So among these nodes we have to consider one node as a reference node having a potential 0. So which one we are considering? The lower one. The lower one we have considered as a 0 potential node or the reference node, and the remaining nodes means nodes 1 and node 2, we have to put the values of unknown voltage, that is we can consider the unknown voltage V1 and unknown voltage V2 for this node 2s are present. Okay. Now we have to put the direction of current. So for this non-reference node, that is one node, we have considered the non-reference node 1 having a voltage of V1 and whatever the branches connected over there, and we are considering the current. Let's consider this I1 current, that is I1 current up to down, I2 current, this is left to right side, and I3 current, this is up to down. This direction of current, this is your choice. You can put the direction of current as per your choice. You can put in any direction, whatever, no problem at all. So whatever the direction you are putting, just you have to consider the voltage level based on your current direction. Okay. Similarly for this node 2 where the voltage is V2, the whatever the 4 branches are mixed together, just we have put the voltage the current, that already we have considered this I2 current through this 4 ohm resistance is left to right, so I2 current will be left to right. And similarly this upper branches current, and we have already considered for this one, for this node 1, that the I1 current is coming, I1 current is coming to the node 1. So obviously this I1 current is coming out from this node 2. So we have considered this I1 current is coming out from this node and it's going into the node 1. And similarly this I5 current is coming out, and I4 current we have considered as a going into the node V2. So we have already considered. Now let's consider the node 1. If we consider this node 1, so how many branches are there? 3 different branches are there. What are the current for these 3 different branches? This current is I1, I2, and I3. Now what is the KCL? We have to apply the KCL for this node because this is our non-reference node. So if we apply the KCL, as per KCL we know the summation of all incoming currents is equals to summation of all outgoing currents. So what is the incoming currents? That is I1. What are the outgoing current? That is I2 and I3. So we can write I1 is equals to I2 plus I3. No problem at all. And now we have to put the values of this current. We know this I1 current in the branch. This I1 current means the I1 current, we have considered this I1 current in the branch consisting with a current source. And if any branch consists any current source, then we have to put the directly that values of current. So it means we can say that I1 current is nothing but the values of 5 ampere. So I1 current we have written over here, this 5 ampere. Similarly, I2 current is originated from this V1 node and going to V2 node, and obviously the path of this I2 current, there is no more current source. No more voltage source, only resistances are there. So what are the voltage difference? The voltage difference is V1 minus V2 divided by this 4. That's written over here. Similarly, I3 current, that is originated from this node 1 and going to the node 0, it means going to the reference node. So we can say the I3 current is originated from this V1 voltage and going to the 0 voltage. So higher voltage minus lower voltage, or the higher potential minus lower potential divided by the resistance. So we can say in place of this I3, V1 minus 0 divided by 2. That's written over here. Okay. Now we are going for this node 2. Node 2, 4 different currents are there. So which one is the incoming and which one is the outgoing? I2, that is the outgoing. I1 that is outgoing. I2 that is coming into the nodes. I5 that is the outgoing from that node. I4 that is also incoming. So we can, here incoming current means I2 and I4, and outgoing current is I1 and I5. So simply we can write as per KCL that I2 plus I4 current is equals to I1 plus I5. So I2, what is this I2 current? I2 current is over here. I2 current, that is left to right. This current is flowing through this 4 ohm resistance and having no more current source. So simply we can write I2 means V1 minus V2 divided by 4. Similarly, in place of I5 we can write V2 minus 0 divided by 6 in place of I5. V2 minus 0 divided by 6. Similarly, for this I4 current, the I4 current branch having a current source. I4 current, we have considered the I4 current and that branch, and the branch consisting a current source. So I4 current having the same value with that current source value, it means the I4 is equals to 10. So this I4 value, that will be obviously 10 ampere, and obviously this I1 current we have considered, and we have considered this I1 is coming out from that node and going to V1, and direction of I1 and direction of this current source is in the same direction. So that's why we have to consider this I1 is equals to 5 ampere. So we have to consider I4 is equals to 10 ampere, as the direction of I4 and 10 ampere in the same direction. So I4 is equals to 10 ampere and I1 is equals to 5 ampere. I2 is equals to V2 minus 0 by 6, and I2 is equals to that is V1 minus V2 by 4. So just we have put it I2, we know the values of this I2 is equals to V1 minus I2, V1 minus V2 by 4. Here it's written V2 minus V1 by 4. It's not because of just simply just we have changed the equation from left side to right side, that's why we have changed it. Now just simply put the value that I2, I1 and I4. If we put the I4 is the left side and I4 and I1 is also right side. So if we interchange these together, as the I1 having a values of 5 and I4 having a values of 10, so just take it in one side, so it will be I4 is 10 and I4 minus I1, if we take it at the left side, so it will be 10 minus 5 is equals to 5. No problem at all. And we are considering I2 in this side, I2 in right side, so there will be one minus will be there. So it means minus I2 will be there in the right side, and that minus is being considered at the same time. That's why it's written as a V2 minus V1 by 4. So plus I2 means V1 minus V2 by 4, and as this I2 is transferred or shifted from left side to right side, so it will be minus of I2. So minus of I2 means just put a minus sign within the values of I2. I2 means V1 minus V2 by 4, and here this minus sign is given because of we have multiplied by that minus because this I2 is shifted from left side to right side. That's why one minus will be there, and that minus is multiplied over here. That's why it's written as a V2 minus V1, right? Otherwise, the actual values of I2 is nothing but a V1 minus V2 by 4, and the values of this I5. This I5 that we know V2 minus 0 divided by 6. So we got just two equation for these two non-reference nodes. Now in the matrix form we can write down the equation and we can solve the values of, we can find the values of V1 and V2, or you can go for this matrix solution, or you can go for the direct solution, direct equation solving for your equation where it contains only the two unknown values, that is V1 and V2. This is one equation having two unknowns, and in previous equation for this node 1 equation there is also two unknowns V1 and V2. So we have two equation and two unknowns we have, and so we can easily solve the value and we can easily find out the values of V1 and V2. And as we can easily find out the values of V1 and V2, simply we can find out the current for any branches. Suppose they are asking me to find out the current through the 2 ohm resistance. So we have considered the current for this 2 ohm resistance, that is I3, and we know the values of I3. What is the values of I3? I3 nothing but a V1 minus 0 divided by 2. So just put the value and you will get the answer. Okay, so that's all. Thank you.